Welcome, and thank you for joining us for Human Kinetics webinar, Understanding and Using Velocity-Based Training to Maximize Sports Performance. My name is Alexis Kuntz, and I'm the Associate Director of Social Media Marketing at Human Kinetics, and I will be the facilitator for today's presentation. The webinar is scheduled for 1 hour. The session is being recorded and will be available for playback. By the end of the day tomorrow, you can expect an email containing the link to the recording. A certificate of participation for today's webinar will also be attached to that email. Due to the large number of participants today, you'll be able to hear me and our presenter, but you'll not be able to speak to us directly. If you have any problems with the audio, you may call in by clicking the, quote, Use Telephone option in the audio tab and dialing in with the number and the audio pin provided. You may also send questions anytime throughout the Questions tab or the chat box in the lower right-hand corner of your screen. We'll allow time at the end of the presentation for a question and answer session. To submit questions during the webinar, use the question function located above the chat function. Just type your questions in the box and click send. I'll collect the questions and provide them to the presenter during the Q&A. So we're looking forward to a great presentation today, but first I'd like to give you a little more information about our presenter. Nunzio Signore is a certified strength and conditioning coach and the owner and operator of Rockland Peak Performance. He's also a member of the American Baseball Biomechanics Society and director of the Pitching Lab in New Jersey. For the past 10 years, he has been one of the most in-demand strength and conditioning coaches in the New York and New Jersey areas, working with players from the Minnesota Twins, Anaheim Angels, New York Yankees, New York Mets, Arizona Diamondbacks, and Seattle Mariners, to name a few. He's written articles for publications such as Inside Pitch Magazine and speaks annually at baseball clinics such as Pitchapalooza, Bridge the Gap, New York Coaches Convention, Be the Best, and Inside Baseball Coaches Conventions. So without further ado, I will hand the presentation over. Welcome, Nunzio.
Thanks, Alexis. Thanks all of you for tuning in. And this is going to be a very interesting 50 minutes. It's a very intense topic to speak about all in 50 minutes. So bear with me. I'm going to try to make this as thorough as possible that I can in 50 minutes, but it's really great that you're going to be able to watch this later. Because this is the type of presentation that you're going to want to really sink into and be able to pause and look at some slides. So if there's something that you don't quite, if we're going a little too quick for you, I apologize, but trying to get a lot of information in here in a short amount of time. And also you can grab the book if you like. I'd like to thank Human Kinetics, first of all, Laura Pulliam and Alexis Kuntz and Mike Mejidas for really making me sound a lot smarter than I really am. Publishing, just going through my my book and helping me out with putting my thoughts on paper. Of course, Dr. Brian Mann, who is a big influence on me, as Yuri Verkhoshansky. These are two guys that I really have learned a lot about velocity-based training from. And if you don't know who they are, I really suggest you dive deep into it to further educate yourself on velocity-based training. And Carl Val is another strength and sport coach that I have much respect for, who also is a big proponent of velocity-based training. This is my book that is now out and available on Human Kinetics. There'll be a coupon code at the end that will help you get this book for 20% off. And without further ado, let's talk about it. In the next 60 minutes, we're going to talk about what is VBT, some of the tools of the trade, why we use it, why it's effective, the special strength zones, understanding some of the metrics, the prerequisites of do you qualify to even use VBT, and we're going to look at some periodization and implementing VBT into the yearly plan of an athlete's program. So how I got started. My aha moment was 2010 to 2015, 4 to 5 year lifespan with my athletes. If I get a kid in high school, I've got them through college. If I get a kid in college, I've got them through college. I generally get 4 to 5 years with my athletes. As a strength and conditioning coach, you know, I was under the impression that let's just keep getting stronger, we will get more powerful. Let's get more stronger, we will get more powerful. I noticed that strength increased in power and vertical jump, and with my baseball players, their throwing velocity began to plateau after year 2. They were getting stronger, but what we were actually trying to achieve as far as power and speed go, that was getting diminishing returns. I started reading Verkhoshansky's Special Strength Training, and I picked up a copy of Dr. Brian Mann's Developing Explosive Athletes because I had heard along the grapevine that these were great texts to help develop power and speed in your athletes with the help of some devices. So I got myself a Tendo unit, I rolled up my sleeves, and I got into the trenches. So what is velocity-based training? It's a method for evaluating the intensity of a given moment, and it calculates displacement in time through the monitoring of bar or body speeds. By doing this, it allows an athlete to train in a specified zone, helping to create a specific training adaptation, as well as measuring displacement in time. We can calculate how fast they're moving the bar, and we're able to, with the load and the velocity, better calculate peak power. So for me personally, I have a lot of athletes and teams in my facility, and I know that me and my coaches, I feel comfortable training 2 to 3 athletes at a time and really being able to focus on if the load is right and form. But after that, as you can see in this picture, when you're dealing with 6, 7, 8, 9 guys at a time in a weight room, I dare anybody to tell me that they can monitor the load of every guy. And, you know, there's a bit of autonomy that comes into play. It allows these athletes, by strapping on a VBT unit, to get external feedback, and it creates a competitive environment, and it makes them responsible for their own training, which is huge in high school athletes when they get into college, because they become role models in the weight room because of their education on how they train themselves. So I apologize for this slide. There's a couple slides in here that had came up sideways, but what you're basically seeing is it takes external feedback on the speed of the lift. Athletes can get immediate feedback on power and intent, which helps translate to great performance in sport. So this athlete is picking up the bar, and as you can see, every time he comes up, right above him, there's a 0.68, a 0.71. That's giving us the speed he is lifting that, okay? On the right-hand side, it will give us an average velocity that he's moving that set, and as we'll learn a little bit later, that correlates to a percentage of his 1 rep max and a special adaptation that we're looking for, whether it be max strength, strength speed, speed strength, or what have you. Tools of the trade. Linear position transducers are the first type of Tendo unit, the most common and the original types of VBT units. It consists of a hardwired cable measuring sensor, such as a potentiometer or rotary encoder. Basically, these things are like tape measures and stopwatches, as Brian Mann would say. They're the gold standard and slightly more reliable than accelerometers, which are strapped on your body. The sensor converts the change in distance of the cable to voltage and ultimately velocity and acceleration. And this is the key thing. It also calculates average force as well as power. Accelerometers do not calculate force. So they are very expensive, and they occupy a rack. They have to be dedicated. They're not easy to move around, but they are the gold standard as far as if you're training one athlete at a time, you can't go wrong. This is the way to go. An accelerometer such as a push band, more recently, they use algorithms to detect start, stop, and bar path. Do not have a hardwired cable to calculate angles, so readings can be slightly more skewed than those of a linear position transducer. But they're very affordable, they're great in team settings, and when ranges are being used, but they currently lack the capability to measure force in real time. So what I will tell you is I have 14 of these units in my facility. Athletes will sign them out, and it's about a week learning curve for them to learn how to use it. My coaches help them with that, but I can tell you, as soon as they start to use it, I watch results go up. The competition factor by getting that external cueing is huge. I'm a big believer in it, and the guys come in now, and to the point where if they're all signed out, they will actually wait to till they can sign one in. So why do we use it? Research in Spain revealed a few key findings about some of the benefits. Gonzalez Badillo, Sanchez Medina, very popular VBT study. People who train with maximal velocity during the concentric phase, and we'll talk about what that is, of a lift or movement, attain better strength and power results than those who do not train with maximal intended velocity. This is creating intent and competition in the athlete when they can see that they're making or not making their velocity. Velocity decreases fairly linearly across a set of traditional strength training exercises, such as bench presses and squats, and velocity is closely related to the percentage of the 1 rep max. We're going to talk about that. It is very closely related. I think it was 0.989 or 0.998 or something like that. I can't remember what the study said, but it's in the book. It's very closely related to a 1 rep max. And why is it effective? For all you coaches out there, you're very aware of the SAID principle, but if you are not, this states that training should create the adaptation or trait that is needed to excel in our desired sport. Basically, you want to train fast to be fast. You want to train heavy to get strong. So one key advantage of VBT is the ability for athletes or coaches to ensure that the desired trait they're trying to achieve is being developed. Every type of strength or trait has a speed. So if we're not training in the required zone, in other words, that desired speed, then we're not really developing the strength or traits we're chasing. And I have a little chart down here. It's a modified chart that I made for my own purposes that GymAware had recently released. And it shows absolute strength, accelerative strength, strength force, strength speed, speed strength, and starting strength. And underneath, it correlates to a 1 rep max. So if we're looking to train absolute max strength, and we know we need to be between 80 and 100% of our 1 rep max, those lower body speed ranges and upper body speed ranges, that's what we're looking for, under 0.50 meters per second. As we get later in the off season, and closer to the competitive season, those speeds will go up because we're starting to get fast. And as we work to the right of that continuum, you will see that the percentage of a 1 rep max as well as the speeds go up. And that's basically a gist of what we're going to talk about today. There's about three or four geeky slides in this presentation. There was no way for me to avoid them. I think they're important. And this is one of them, so bear with me. There's 4 ways a cell produces force and produces a stimulus. Myofibril hypertrophy. This is the actin and myosin contractile proteins. This is our accelerative strength, submax strength, or what we call sport-specific hypertrophy. Okay, it's 60 to 80% of a 1 rep max, or I like to go 75 to 85, as you can see on the left side. This is what we use to train the type 2 fiber, and it's not quite max strength. The next type of adaptation we look for is max strength, and that's the size principle. We're trying to recruit the high threshold motor units as fast as possible. And that happens at heavier loads greater than 80%, 2 to 5 reps. And that is our VBT. We're going to look at that under 0.50 meters per second. Then we get to rate coding, strength, speed, speed, strength. This is when we're starting to transfer to sport and trying to take that strength in the early off season, turning it into power. And that's how fast we could send that signal down the nervous system, okay? For different athletes, it happens at different percentages of a 1 rep max. For some, it's 20, for some, it's 40, for some, it's 50, 60. That all depends on the athlete, and VBT rules here because it will give you peak power output, and you can work and keep increasing that percentage of the 1 rep max until you hit peak power. For some, it might be 30, for some, it might be 40, but when you do find it, you'll know what number you're looking for to train at peak power. And then sarcoplasmic reticulation. This is how quickly the system can release and reabsorb calcium and other substrates. Basically, this is our endurance, how long we can produce power for, and it's also how quickly we can recover from strenuous activity. That is doing series of sets and reps with very little break. I call it explosive repeats, and it's done with very little body weight to 20% of a one rep max. We're doing this in the end of the off season and throughout the course of the in season, which we'll talk about a bit. So here they are, the special strength zones. These are the zones that we look at throughout the year to create specific adaptations. These can be at different times of the year for different sports, but they're the same for all sports. Everybody's got to train strength. Everybody's got to train power. Everybody's got to train speed, okay? And some sort of endurance. So strength, max strength, 60 to 100% of one rep max. There's two types here. There's absolute strength, which we talked about, the size principle. That's 80 to 100%, and that happens at 0.5 meters per second or less. For our upper body ranges, if you look here underneath, it's basically about 0.10 less, and that is because there is a much more mechanical advantage on upper body exercises because the length of the arms make the movement shorter. We can generally grind out reps at lower velocities. So if you look across this meter, they're all basically lower, about 1.0, 1.5 lower, and that is based off of my findings. And Ty Terrell also, I believe he's a strength coach for the Houston Rockets. He talked about this a bit as well. So absolute strength and accelerative strength, that's our early off season. Then we're going to transfer to sport peak power. That happens, like we said, for different athletes at different percentages, but lives somewhere around 0.80 to 1.2, and that's basically somewhere between 30 to 60% of your one rep max. We use strength speed to train this power. We use speed strength to train this power. Some athletes need to train force more than velocity to create that power, and they'll use strength speed. Some athletes need to train velocity more than force, and that takes precedence. And then starting strength is the ability to rapidly overcome inertia, basically from a dead stop. So understanding the metrics. VBT gives us crucial feedback associated with a movement. So the movements that it shows us are average and peak concentric velocities, okay, on both speed and ultimately power of the movement. LPTs, linear position transducers, as I said before, can also give us readings on force. It also gives us velocity. We can use velocity cutoffs and losses. The velocity cutoffs tells us when to end a set, which is called a mean velocity threshold, and a percentage of loss between the first or best rep in the set is telling us about our velocity loss and how much we want to get tear down of that muscle. And we're going to talk about all of these in the next upcoming slides. And it also gives us crucial feedback as far as auto-regulation. How ready is the athlete on that specific day based off of fatigue from stress or lack of sleep or whatever, dehydration, whatever have you. So average mean concentric velocity. What this is this is the average speed during the entire concentric portion of the exercise. So if we're looking at a bench press, we're looking for it from the beginning the movement starts all the way till it locks out. This includes the time spent purposely slowing down the speed of the load or movement as a natural reflex in order to avoid joint, tendon, and muscle injuries, otherwise known as deceleration. The lighter the weight we're using, the more the body has to decelerate the movement due to the speed at the end of the lift. As lifts get closer to 60 to 70% of a one rep max, obviously we're not moving the load as quickly because of the intensity of the load, so there is not as much deceleration involved. Peak concentric velocity. So when we're using these really light lifts, we can use peak concentric velocity. It's usually calculating every 5 to 10 milliseconds, and it's simply the peak speed during the concentric portion of the exercise. It's basically giving us the quickest 5 to 10 milliseconds of the lift. This removes the time spent decelerating, which on loads less than 40 to 50% of 1 rep max can comprise upwards of 50% of the entire concentric contraction. So basically, when we're doing hang cleans and we're doing ballistic movements such as trap bar jumps or weighted jumps, these movements have a lot of deceleration, so to lock out, and it gives us the quickest 5 to 10 milliseconds of that lift. Mean velocity threshold, stopping when the velocity drops. We're going to talk about using cutoffs. This is another one of those geeky slides. So basically what this slide is telling me is when I'm looking at an athlete and I don't want to bring him to failure, I personally, unless it's a bodybuilder, I do not bring athletes to failure. This creates residual soreness for number one, that creates the next day play, or also it's a recipe for disaster. If they don't make it and they don't have a spotter, this can be a really bad scene. It's great for using for teams when the situation does not always allow for spotting. So it's basically how many reps you have left in the tank. Okay, so it's based on a study by Jaidovtsev et al. On the lower body, we go with I set the cutoff for 0.30. That lets me know that when an athlete's squatting, and once he gets down to 0.30 on his reps and it's getting heavier for him, I will set a tone that lets me know that he's at 0.30. We cut the lift off there. If the athlete seems like he has a lot more left in the tank, then this means we have a stronger athlete, and we can set that cutoff as low as 0.20. I never, ever go below 0.20. I hardly ever go below 0.25. But generally, for safety purposes, we start with 0.30. This will let me know that the athlete has approximately 1 or 3, if he's really strong, left in the tank. And for the upper body, once again, because of the mechanical advantage of the movement, we use a little bit lower. I know for me on a bench press, I can go down to about 0.17 before I have 1 left in the tank. So I just happen to be good at bench pressing. But generally we set that for 0.25 to 0.35. This is really, really important for younger athletes because we do not need athletes who have been lifting 1 or 2 years who start using VBT. We do not want to allow them to just decide on their own if they've got 1 left. That could be a really bad scene. So I tell them, set it for 0.30. When you hear it, you're done. When you hear the tone, you're done. So that's how we use velocity cutoffs. Velocity loss percentages. So we can look at the cutoff, or we can set it for a percentage of their loss. And I'm going to show you what I mean by that, I believe, in the next slide. So you could set the percentage of loss based off the first or the highest rep in the set. The device will ask you, do you want to set your velocity loss based off of your highest rep in your set, which sometimes could be the 2nd or 3rd rep, or do you want to base it off the first? I generally base it off of the first, even though I know a lot of times my 2nd rep is higher. This allows for a higher quality of work, as well as pinpointing breakdown of the cross-sectional area of the muscle according to the specific training adaptations desired. Here's examples of velocity losses associated with specific adaptations. For training hypertrophy, I'm going to look for 40 to 50% of a loss from the first rep. If I'm looking for strength, I'm going to look for 20 to 30, but honestly, I go 10 to 20. This is something that I should probably correct. You can go 20 to 30, but because we're training strength and force output, I don't really want to go higher than 20. And then for power or speed, we want that breakdown to be below 10 or 15%, because if it's any higher, we're really not training fast twitch power or speed. It's basically becoming a big conditioning session. So the following 3 examples are different ways I incorporate that velocity cutoffs and or velocity loss into my programs when training for hypertrophy, power, and or submax strength. Guys, this is another one of those geeky slides. So if you're going to watch this later, this is one that you could spend some time looking on. So there's three ways I do it. I either manipulate the reps, I manipulate the sets, or I manipulate the load, the amount of weight. So an example is a 250-pound, let's say, squat. If we're going to do it for 8 and we want to train hypertrophy, we're going to look for 0.70 is our starting speed because we want to be able to get mass amounts of reps. So we use 40 to 70% of a 1 rep max for hypertrophy. The reps end when the target velocity of 0.35, okay, that's 50% of 0.70. That will bring us close to failure, happens. And note, for hypertrophy, this should be anywhere between 12 to 20 reps with 1 to 2 left in the tank, reps in reserve. So if I get to 0.35 and I've only done 6 or 8 reps at a 7.0, that means that my weight is not heavy enough. And I need to up my reps closer to 20. And I need to lighten up the weight so I can get more time under tension and get those 12 to 20 reps. And that's that 8 times question mark reps. Okay, the reason the question mark reps are there is because it depends where you're reaching that 3.5. For some guys, it might be 12. For some guys, it might be 20 if we're using a 0.70 starting time. If I manipulate the sets, I do this for when I'm training endurance and when I'm training power. Okay, you can see I use this for speed or power. Okay, once again, we're in a strength speed zone because we're training power. We're looking for under 10% loss. Okay, so what happens is if that 250 pounds, I'm going to do as many sets of 3 reps. Okay, let's say I'm at a 0.80 meters per second, which kind of relates to 50% of your 1 rep max. Okay, the sets end when the average set velocity drops below 0.72. Okay, that's 10% of that 0.80. I will set my VBT unit for a 10% velocity loss, or I can set it for a velocity threshold 0.72. And when I hit 0.72, it will tell me that when I can no longer maintain 3 reps at 0.72, I'm done my sets. I ideally like to use 6 to 10 sets of 3 reps. So if you're hitting your velocity loss is greater than 10%, greater than that 0.72, and you've only done 4 or 5 sets, I would lighten the load so we can actually get more before fatigue sets in. And this is the beauty of using velocity-based training, because other than that, you're just estimating how explosive you're being. And then the last one is the manipulation of the load. This is what I use when I'm strength training or power development. If I take 250 and I'm doing it for 8 sets of 3, and I'm using a 0.60, and we're using 0.60 because that roughly will be set 70%, and I'm working sub-max strength. When that reload drops below 4.8, that's 0.48, that's 20% of 0.60. Okay, once again, I can set that the VBT unit at a 20% loss, or I can set it at 0.48 if I'm looking for that loss. Okay, it will give me a tone. If I'm dropping more than 20%, I'm going to lighten the load, and we can lighten this load from set to set. We can lighten the load on a day when we're not feeling as great, which is auto-regulation, and it allows us to train to the readiness, and it tells us when we can lower the weight. So we can lower that weight during the course of 1 training session over the course of 8 sets, maybe by set 4 or 5, we're starting to get a little tired. Instead of muscling through that, we're going to actually lower the load and train in that 0.60 if we're trying to produce really great numbers in force. Auto-regulation. Auto-regulation refers to a system that manages volume to regulate individual differences in an athlete's work capacity. I say individual because every athlete has different factors in their life that are creating stress. And when we train, we must consider these differences in readiness. And it's caused by fatigue, not just from training alone, but all the stressors in life, relationship problems, family problems, studying, finals, dehydration, a late night out. VBT takes all of this into consideration. And I'm going to show an example of how these percentages of a 1 rep max can change as much as 15 to 20% day to day based on any of those stress parameters like loss of sleep or finals or family problems. So by utilizing this VBT, we could take these parameters into account by locking into a percentage of a bar or body speed, then percentage of a 1 rep max. So we'll get a daily number after each rep and set, and we can see if the weight needs to be decreased due to the fatigue of that day, or is it increased? Am I feeling new strength gains? Am I feeling good today? We can go up. So for example, if I'm bench pressing on day 1, 200, and I'm looking for roughly a 6'2" number, okay, that equates to 285 pound 1 rep max. Okay, if I'm moving 200 pounds at 0.62, that relates roughly to a 285 pound 1 rep max. Okay, I come in on day 2, and for whatever reason, I'm working up to my 200 pounds, and all of a sudden I'm already at that 6'1", 6'2", and I'm only at 175 pounds. Okay, obviously I'm not feeling as strong that day for whatever reason, overtraining, stress, what have you. Okay, as you can see, my 1 rep max that day is roughly 250 pounds. Okay, that's 35 pounds less due to stress. Okay, I'm not going to just load up that 200 and hit it because that's what I did on day 1. That's just not smart training. We will not get the adaptation we're looking for. If we're looking for peak force, that happens around 0.60. If I have to bring that 200 up on day 2, I'm going to be down in the 5s, and I'm not going to create that true force production that I'm looking for. And also, if I'm not feeling great, I could get hurt. And then on day 3, I come in, great sleep, resolved all my issues. I come in, I'm working up, and maybe 200 pounds is at 0.65. I'm like, wow, I can go up a little bit. And now I'm at 210 for 6'3". Now I'm at a 300 pound 1 rep max. And you can see how that 1 rep max fluctuates from day to day based off of the weight that I'm pulling and my speed. So all 3 days utilize the desired velocity, approximately 0.60, but stress and fatigue affected the loads used and ultimately the athlete's estimated 1 rep max for that day. So this is how we auto-regulate and get our estimated 1 rep max, and we auto-regulate our training based off of our body. So here's how we calculate power. Okay, once in the mid off season, we start to transfer to sport. Okay, so power, just getting a power number is not enough. There are different ways we can achieve power, and as we know or don't know, power is force times velocity. Peak power can be produced in either the strength speed or the speed strength zones. Okay, those zones, strength speed being roughly 7.5 to 1.0, and speed strength roughly 1.0 to 1.2. Once again, they differ for the athletes slightly. Different athletes produce their highest power numbers in either of these 2 zones. Okay, some athletes produce most power in strength speed. Some athletes produce it in speed strength. How do we know? We get a peak power rating off of our velocity on VBT. It will give us, at the end of the lift, it will not only give us the speed, but it will give us our power output in watts based off of the load and velocity. And we can go up in weight, and as our power goes up, we keep putting on weight. Once we hit diminishing returns and our power goes down, we know that more weight is not necessarily better anymore to achieve ultimate power. I like to lean a bit more on the velocity side with my athletes for most sports due to the rapid time component of in-game play. That peak power, from my experience, that lives around somewhere between 0.85 or 9 to 1.1. It's a really fine line. 1.0 is kind of that middle area between strength, speed, and speed, strength. And that's a really, that's where most athletes create their peak power. So I want to give you an example of how two different athletes in the same sport can create power differently. 4,000 watts of power can be achieved through multiple combinations of force and velocity. Athlete one is an offensive lineman, okay? These guys generally work on the force side of power, okay? Because they constantly have a force applied against them for periods of time on every play, fighting off another lineman, okay? Peak power produced for a squat was 175 pounds at 75 meters per second, okay? That is in the strength speed side, okay? And he may be producing 800 watts of power from his force and 500 watts of power from the speed of the movement, okay? And that's his 4,000 watts. Whereas we have a quarterback who doesn't really use that. He really needs to be on the velocity side more. He has to run, he has to jump, he has to throw really quickly, and he doesn't have a resistance on him for the entirety of the play. So this athlete, he produces his peak power maybe with 120 pounds at 1.0, okay? He's now getting his 800 watts of power from the velocity side. From the speed side, because he's at a faster speed, he's at a less weight for himself, and that's maybe 500 watts of force, okay? He's in the speed strength zone. So wherever peak power happens, peak wattage, that is the speed you look for. It much depends on the type of athlete we have in front of us, and that's why VBT is so valuable, because it will not only tell us the speed we're moving, but it will tell us if that is the appropriate speed to create peak power by also getting a reading on the wattage we're producing based off of the load and the speed of the lift. Prerequisites. Heavier is not always better. Tudor Bompa said all strength relates back to absolute strength, but getting stronger is only part of the equation. Expressing force quickly, which is our rate coding, is gold in sports performance. Even more than myofibril strength at 80 to 95, even more than our size principle. We need absolute strength because it's what all other types of strength, power, speed sit on, but at some point, we need to be able to get fast. If you want to be fast, at some point, we need to transfer training to be fast as well. So speed of the lift matters for transfer of sport. Later in the off season, we need to start using VBT to make sure we're moving the weight quickly. And don't forget, you're still the coach. So this is, I can't emphasize this enough. VBT dictates the load. It does not dictate form or technique. So make sure your guys, which brings us to our qualifications, have good form, okay? What I look for in my guys, I look for at least 1 to 2 years of prior lifting experience. It is really, it's really not a great idea to just strap VBT on a novice athlete. Their form is not good. They're going to do whatever they can to get that speed, and, you know, creating a competitive environment with a kid who doesn't have good form is a recipe for disaster. They're going to arch that back. They're going to round that back. They're going to pull with their arms. They're going to get a forward head. They're going to do whatever they can to get that weight up. So I look for a guy to have at least 1 to 2 years of prior lifting experience. No one in my gym trains on VBT unless they're 17 years or older. I make it a privilege for my 11th and 12th graders to get VBT. They have to qualify. They have to have been with us for at least a year to a year and a half, and they need to have good form. On the right is a photo of a graph by, I believe it was Vern Gambetta, who showed what he looks for from the bottom up, and that work capacity, mobility, and conditioning. If you do not have good mobility and you don't have good conditioning, it's not a great idea to use VBT yet, because once again, it plays hand in hand with not having great form. And if you're tired, you know, that's that's the enemy, you know, of good form. So if your work capacity is low and you don't have good mobility, you're not going to get into these efficient positions. You're not ready for VBT. But once proper form is established, VBT comes into play. We work on base strength and we work on transfer to specific strength and power up that chain all the way into in season when we're working on speed. Don't overdo it. Only after form is cleaned up, and you know, guys, please, no more than 3 exercises per workout. You don't want to slap VBT on everything you have. It becomes, I use it for the prime movers. I basically use it on my deadlift. I use it on my squat. I'll use it on pull-ups. I'll use it on incline rows. I'll use it on bench press. I don't use it on exercises that are designed for mobility and stability. It's a little dumb to be trying to see how fast you're moving something when you're working on mobility or you're working on something with stability like an overhead squat or a Turkish get-up, where we're not really interested in how fast you're doing it, but how well you're creating stability in those joints and how efficiently you're creating movement through the chain to efficiently do these exercises. So the last few slides, we're going to talk about implementing VBT into the annual plan. I'm going to use a baseball athlete because this is the clientele that I train. 85, I would say 85 to 90% of my athletes are baseball players. But the periodization changes, but what we train in these periods does not. The amount of time we spend in them does, and when they happen during the year, that changes from sport to sport. My months here are what happens for me with my high school and college and pro baseball players. These months will be different for a soccer player. These months will be different for a lacrosse player. These months will be different for a football player, what have you. So in the preparatory period, we have anatomical adaptation. This is getting the tissues ready, okay, to do heavier lifting. That's submax, hypertrophy 2, and absolute strength. We use that anatomical adaptation to develop tensile strength and tissue quality and to get ready to lift heavier. So the use of VBT is only relevant for determining the starting load because we use slow eccentric movements and we use isometric loading at the bottom. We're not interested in how quickly you're moving the weight because we already know we're trying to go really close to failure. And the weight is going to get really slow. We need a lot of reps. And as a result, we need the VBT number to be higher. And that's why I look for around 7.0 to 8.0 as a starting weight. Once I get 7.0 to 8.0, that tells me what weight to look for my 10 to 20 reps. And that's why we use it. Hypertrophy, I don't use much, but it's very similar to anatomical adaptation. We're basically looking for time under tension, high reps, same thing, 40 to 50% tear down of muscle, creates a lot of soreness due to the eccentric component and the holds, and it's used mostly in bodybuilding, which is not a good look for my guys or most athletes that are trying to move fast. Submax strength, this is all what we train in the early and mid off season, okay? Submax strength, once we strengthen the tissue and the tendons, we go to submax strength hypertrophy 2. This is using heavier loads, 60 to 80. We're working on force production. We're working on, at the higher end of that with hypertrophy 2, 75 to 85%. We're looking for hypertrophy of the prime movers, the fast twitch fiber, okay, different than regular hypertrophy. And we're using 5.0 to 7.5. That's accelerative strength. And then once we use accelerative strength, we're into absolute strength. This is where we're going to work on the size principle, okay? We're looking for greater than 80% of a 1 rep max. We're generally doing 3 to 5 reps. And I'm looking that greater than 80 is loads slower than 0.50 meters per second, and we're only looking for velo losses of 10 to 20% because we're looking for all good reps with not a lot of muscle teardown. We've got that up in the hypertrophy section with our bigger velocity losses. We're trying to create absolute strength. We're looking for the fast twitch motor units to recruit all at the same time and quickly. So we're not looking for a lot of fatigue. We're looking for heavy weight lifted with minimal teardown. Transition later in the off season, we transition to sport. This is January and February, March for my guys. This is where we use combinations of strength. So we're at that absolute strength, and we'll do a set of 3 at 0.50 or less, and then we'll hit strength, speed, or speed, strength, wherever that athlete, remember, we said creates peak power. We'll have him bang out a set of 3 to 5. Sometimes this is body weight if he's in speed strength, or trap bar jumps, or something of that matter immediately after. So we're going to activate with the heavier weight, then we're going to potentiate with those lighter weights. And then in season, we use undulating, more nonlinear programming where we train strength, power, and power endurance all at one time in one session or throughout the course of 1 week. We don't break it up like we do here throughout the course of the season because we're trying to work on only the things in season that the athlete is losing. They're called training residuals, okay? And we'll talk about that. So I'm just going to talk about really quickly each one of these, and then I'm going to open it up to questions. So in the early preparatory period, we talked about anatomical adaptation. This is 0.70 to 0.80 for 12 to 20 reps. I like to use a 4:00 tempo to grab that eccentric component. And sometimes I'll use a 3:20 and hold it in the bottom position for 2. The main goal is to improve tensile strength and regroove good movement patterns, which is great for people coming back from injuries because we're using lighter loads, okay? But we are going close to failure. So using that isometric hold in the low position increases the time under tension, solidifies movement patterns, and both tissue prep and hypertrophy phases help increase applications. And once again, like I said before, use of VBT is only relevant in this phase for determining the starting load. We are not looking for what our velocity is on every load. Our starting load, what we're looking for is this 30 to 40, 40 to 50% of a velocity loss where we'll set the VBT unit to give us a signal when we're at that loss. And we want to make sure we're at that loss within this rep scheme. If not, we need to either raise or lower the load. In the mid-preparatory pre-season, sub-max strength, this is where I use hypertrophy. This is where I use 6 to 9 reps at 5:0 to 7:5, 60-80% for sub-max strength, 70 to 80 for hypertrophy 2, a little heavier. And we're looking for velocity losses of 10 to 20 for sub-max strength because we want pure strength with not a lot of teardown, and 20 to 40 on hypertrophy 2 of the first or best rep for hypertrophy 2 to get a little bit more teardown of the prime movers. The main goal is the ability to coordinate all muscles in the kinetic chain in a single action. It's coordination. We're using a heavy enough weight to activate all the muscles, but we're using a light enough weight that we can still control our coordination, okay? And that's intermuscular coordination. And then we've primed the tendons. We've started some hypertrophy. We've gotten into submax strength loading, and now we're going to go heavy. Okay, for about 4 weeks, I go heavy. 6 weeks, that's 2 to 5 reps at under 5:0. This is greater than an 80% of a 1 rep max with velo losses once again of 10 to 20 of the first or best rep. And this is intramuscular coordination. This is the capacity to recruit as many motor units as possible in the shortest amount of time. This is basically strength, okay? So that's why we're doing low reps with high weight. The high weight kicks more muscles in at the same time than lighter weight, and we're doing lighter reps, lower reps because we're using a heavier load and we want to maintain the integrity of the lift. In the later off season, we're going to take that strength we've just built up and we're going to transition it to sport specific power. strength, power, post-activation potentiation, which I explained before, where it's a combination of absolute strength for 2 to 5 reps at under 0.50, and then either strength speed, and there's your velocities, or speed strength at higher velocities, depending on the athlete and where they produce their peak power. And we're looking for velocities of under 10% for power and 10 to 20 for our strength. So when we're doing that absolute strength for 2 to 5 reps, we're looking for 10 to 20% loss, no more. And then when we're doing our second act, our potentiation with our strength speed or our speed strength exercise, our more ballistic movements, we're looking for power, and we're looking for under 10% velocity loss to make sure we're maintaining power. It's once again, it's training intramuscular coordination, it's training alactic power, it's using the creatine phosphate system, and we're working on power endurance. It's important to not only train explosively, but we have to be able to do it over and over again. So training for power endurance requires on calling all 3 energy systems and working together to get the job done. And that's when we're using our strength speed and our speed strength zones when we're doing series of sets. Here's an example of what post-activation potentiation is. He's going to use 80 to 90% of his 1 rep max. He's going to activate the glutes and the hamstrings with a hip lift, okay? A hip thrust. He'll take about a minute break, and then he'll get in the bar, and he'll use 20 to 40% of his 1 rep max. This is 135, and I'm just using it as an example. And he's using it, and he's jumping with it, and he's activating the same glutes and hamstrings that we activated. He's now potentiating it, the muscle, by using a more ballistic movement. That's post-activation potentiation, and it's usually done for me 8 weeks before the season begins. In season, management of training residuals. Playing sports makes athletes better. Technical side, but it does not make them stronger. We have to figure out what we lose. And in the in-season for pitchers, I train in one session. I'll train 40% of their session will train absolute strength, 40% will train power, and 20% will train power endurance. These are the 3 traits that baseball players tend to lose once playing starts. Okay. You can see it's different for position players. Once again, this is the difference maybe between a lineman, offensive lineman, and a quarterback. So Tudor Bompa has a great article on training residuals and what different athletes lose in their season. And this is my book, Velocity-Based Training, How to Apply Science, Tech, and Data to Maximize Performance. And you can use the promo code for VBT20 and get 20% off the Velocity-Based Training. You can go to the us.humankinetics.com website, and this discount expires on June 30th. Thanks. This is me. This is my Twitter page. You can also email me at nunzio@rocklandpeakperformance.com. This is my facility, Rockland Peak Performance. And I'd like to thank everybody for being here, tuning in. Like I said, it's a lot of information, but please go back and watch the recording where you can actually watch at your own time and kind of sink into some of these slides. With that, I'm going to turn it back over to you, Alexa.
Okay, thanks. So Nunzio, while you're speaking, thank you for a great presentation. We had a few questions come in, and I will open it now for if other people want to add their questions to the questions tab, go ahead and do that now. So one of them we received is, what adjustments would you make for masters athletes?
Okay, for masters athletes, these guys generally are strong enough unless they're power lifters. My guys that are reaching an elite level of athlete, they're generally going to spend the majority of their time working on power and speed strength and strength speed, coordination, all the ways they can apply that that elite strength that they already have. Master athletes are master athletes for a reason. Most of them are strong enough. If you want to increase their performance, I would increase their speed. I would feed them max strength maybe once a week, once every 10 days. I would look for that below 0.50 meters per second, just to actually make sure we're maintaining that strength. That's that absolute strength. And I would work on accelerative strength to increase force production. And I would work on anything above, I would work on the heaviest I would go most of the time would be anything above 60% of a 1 rep max.
Okay. We have another person say that they currently use Rep 1 unit for bar speeds, but it doesn't configure power. And the question is, it seems like it measures everything else, but their question is the easiest way to figure power then.
The easiest way to figure power is through a formula. That's a tough question that I really can't answer. I know if it's force times velocity or force times acceleration, but I don't personally have that formula. You can look it up online, but I would suggest getting a unit that gives you power. I know the push units give you power. That's huge for me because in the late off season, all I'm looking at is power percentage. Where are they creating peak power? If I've got a guy with a CMJ jump, weighted vest CMJ jump, and he's creating power at 0.85, and we know we're in a strength speed zone, and he's creating 3,000 watts of power, and then I load him up a little heavier, and he's creating 3,200 watts of power, and then I load him up a little heavier, and he creates 2,900 watts of power. I can hone in on what load he needs to create peak power and have him work at that load. So I would highly suggest getting a unit that, most of them calculate power. You should get one that calculates power. That would be my best suggestion to you.
Okay. All right. Another question we received is, how do you work strength, power, and power endurance into the same session? And then what order would you use for each of these?
I would work strength power because it is a heavier load. I would work strength power into the session first. And then basically my power endurance is done for series. So I would work strength power. Say I'm going to look for a guy and he's going to perform 8 sets of 3 at 0.80 meters per second. Okay, that's going to put him in the strength speed zone. That's going to put him in the power zone. And then when I want to work on power endurance, that is more specific to the sport. I'm going to give him maybe 6 sets of 3 with whatever the break needed. For field athletes, I make that a 10-second break because they sprint, they stop, they sprint, they stop. So he would do 6 sets of 3, say, weighted jumps or body weight jumps, take a 10-second break, okay, in between each set of 3. So we'll do a set of 3, 10-second break, set of 3, 10-second break for 6 sets. I would take a 2-minute break, and then I would do another series of 6 sets of 3 with 10-second breaks in between the reps. So that way I'm working within the sport. For me, I use 30 seconds because baseball is ballistic for 1 second, and then it takes a 30-second break in between pitches. So for my pitchers, they're going to do 8 sets of 3, maybe split squat jumps or Haydns, and they're going to take 30 seconds in between each set of 3 or 5, and then they're going to do that for 8 sets. And they're going to take 2-minute break, and I may give them 3 series of that to simulate a couple innings. And that's how I would do it. I use the power endurance as a finisher.
Okay. I think we have enough time. We'll do 2 more questions. One of them is, could you elaborate a bit more as to why accelerometers cannot be used to calculate force?
An accelerometer can be used to calculate force. The accelerometers on the market, they have a tendency of wanting you to spend thousands of dollars on a portal where they will calculate it for you. I believe that an accelerometer can calculate force, but it's at a high cost for a portal. The reason that tender units calculated very easily is because it's an actual measurement, whereas an accelerometer is kind of creating a formula based off of the movement in space and time, and it doesn't really give you an adequate description. But I believe that accelerometers, I said they can't calculate force. I believe they can calculate force. There's a lot of work involved, and the portal will do it for you. It just comes at a high cost.
Okay, and there was a simpler question here that I think would be helpful for everybody. Is how do you calculate 1 rep max using VBT?
Okay, what we do is we take the athlete in. We set up, like say we're doing a trap bar deadlift 1 rep max. I'm going to put light load on, and when I'm going to take, like we take 2 times his body weight. So if we have a 200-pound male, we're looking for a 400-pound 1 rep max. We're only going to use that to get our starting loads. Everybody, you're supposed to be able to deadlift 2 times your body weight, but we know that a lot of guys cannot. So what I do is I start at 40% of a 2 times body weight. So I would take 400 pounds and I would take 40% of that, and I would have him lift it for 3. I would take a 90-second break. I would put 50% on. I would have him lift it for 3. I would put 60% on after 90 seconds, have him lift it for 3. And wherever I start to see him get down to about 3.0 or 4.0, I'm going to cut it at like 4.0, because I'm not looking for an actual 1 rep max, because with a lot of guys that can create a problem. So once I get to 4.0, I know that that's going to correlate to 80-90% of my 1 rep max. For a younger athlete, I'm going to take it to 75% only, and I'm going to look for, say, 0.60. Okay, and that will tell me that he's at 0.60 will tell me he's at 60% of his 1 rep max at that weight. And then I will calculate the weight he just lifted. And if he's at 60%, that will tell me what his 1 rep max is. If he moves 200 pounds at 0.8, maybe that tells me that he's at 50% of his 1 rep max. That means his 1 rep max is 400. If he's moving 200 pounds at 0.40, that's 90% of his 1 rep max. That means that maybe his 1 rep max is only 250, but you'll look at the percentage of what 0.40 correlates to and the weight he's lifting, and that's going to tell you if he's lifting at 4.0, which is 95%, and he's lifting 200 pounds, he's lifting 95% roughly of his estimated 1 rep max.
Okay, and then just one last question, and you addressed this in your presentation itself, but somebody's asked about a recommendation for using VBT for training 14-year-old athletes, and I think you addressed this was probably not the best choice, but can you just reiterate that?
I would never use VBT on a 14-year-old athlete. There's no point in it. We know what they need to train. We're not looking for a specific training adaptation in a 14-year-old. We're looking for strength gains. We're looking for strength gains all the way up until they're 16 years old, 17 years old. There's one, just get them strong. 14-year-old needs to A, have fun, and B, they just need to learn how to move properly, and they're going to show great gains without VBT. It's when we get into 1, 2, 3 years of lifting weight, and strength is just not enough anymore. That's when we implement VBT.
Okay, thank you for reiterating. All right, so I just wanted to say thank you again to everyone for joining today's presentation. And Nunzio, I want to thank you for just a great presentation for everybody. You can purchase the book Training on our website at us.humankinetics.com. A couple people had asked throughout, what is that promo code again? It's VBT20, and that can be used at us.humankinetics.com. And you will be receiving a recording of today's presentation via email, and it should arrive within a day or two in your inbox. So thank you again, and I hope everyone has a great afternoon.
Thanks, Alexis.
Thank you. Bye-bye.
Bye-bye.